on that in a moment. And then this is a framework. A framework means that even though we are giving or we're developing tooling, it's not a product by itself. It's a framework for other companies and other protocols to build on top of. So we've been developing reference implementations for most of the components, but the idea is that this serves as a common layer for people to build on top of. All the components have been very modularized. It was very important for the OIF framework to be very modular, very compatible with new protocols, and being able to facilitate integration with protocols that may have their own complexities. So what is the benefit of OIF as a framework? The main benefit is being able to plug and play new components, new wallets, new networks, new protocols very easily with the same API. So imagine we have an ecosystem where multiple wallets are compatible with OIF, multiple solver networks, which we will go in a little bit on what a solver network is, operate within different networks. Now, if we have a new wallet, this wallet is automatically able to interact with every single piece across the stack because of the common APIs and modules. If a new protocol wants to run a solver and operate and provide liquidity and do things, it's also very easy for them to just get running and get exposure to all of the wallets straight. Chain mainly, but there is already a standard that we will go more in depth later to put that intent on chain and for solvers to pick them up. Once the intent has been opened on chain, that can be done either by the user directly or by the solver opening on their behalf, the liquidity gets screwed. The OIF is very modular in the scroll options. You can have a direct scroll into the smart contract, but you can also leverage resource logs for doing this. Resource logs, you can research much more onto that, but it's basically a technology that allows you to have a common liquidity pool that just by doing signatures can be moved with the help of a off-chain party. Once the liquidity is properly secured in a contract, in an escrow, the solver then fills your intent. So you straight away get the output money. This is done through an output settler contract, which is also very modular and allows you to do further actions once the intent is fulfilled. It's not just transferring a token, it can be transfer a token and call a contract and kickstart a chain reaction of different things. This action will create a proof that an oracle has to then forward back to the origin network for the solver to claim the assets that they now belong to them. This Oracle is also very, very modular in the way that it's structured, and it allows solver networks and users to adapt to the protocols available to them, but also for the trust assumptions required for different types of operations. You may have smaller transfers that you're okay with using a centralized Oracle, while if you want to move like $5 million, you may want to have like a more secure Oracle that ensures full completion and full trustlessness. I'm pretty sure the two voices in your head also are pretty disturbing, so sorry for that. So what is OpenZeppelin building? When I was thinking about this, like, where is the camera? Hello. You remember the Steve Jobs iPhone presentation? Like, it's a phone. It's an iPhone. It's like three things in one. OIF is kind of on the same vibe. So I'm not gonna do like Steve Jobs wannabe. I'm very far from that. But OIF builds on that same ethos in the sense that we are building reference implementations on everything that is required through the protocol. So we are building smart contracts, which is the core kind of base of the OIF. It's an on-chain protocol and should always be fully available on-chain. We are building a solver which allows for new networks to like just take them, run it, provide their own liquidity, and get started as part of this ecosystem without having to go and talk with other providers. And we are building a REST API to facilitate a standard way for communicating with that solver. When we build all of these things, we also realize that wallets will have to connect to multiple solvers to get more quotes. So we also built an aggregator that I will explain a little bit later. So smart contracts. Smart contracts we are doing in collaboration with LiFi. So something that is very important for IF is like it's not just OpenZeppelin. It's a Ethereum Foundation like project that multiple projects are collaborating into. It's not just OpenZeppelin. So smart contracts have been collaborated along with LiFi. They are the main core contributor. They are very, very modular and extensible. We have like the input and the output contracts, and they all allow for extra actions and very like customizable approach to things. They allow, as I said earlier, for like kickstarting a chain reaction where when you complete your intent, you can call with a specific data to a specific contract, and that may kind of start another intent or do more things on other protocols. It's also very modular, both in terms of how the money is secure and how the validation is proven. So right now we have support for resource locks, and we have support for direct escrow of tokens, either through like permit 2. We have also support for 309, which is also a signature protocol a signature standard to facilitate signing. And for oracles, we actually have like 5 to 10 different oracles, and the list is just growing because we've seen a lot of interest from oracle providers to be integrated into the standard. So this modularity allows for users and protocols to have a very clear trust assumption among them. So you may have solvers that prefer some oracles, while others like have a lighter requirements for trust. We are also building the solver. The solver is the primary off-chain component. It's the component that actually fills the intent and the component that handles all the liquidity. It's built in Rust, the reference implementation, and it's very modular to like configure every single detail that a solver may want. So you want to adapt how fees are applied to your project. We have a module for that. You want to adapt which oracles you support. We have a module for that. So the idea is that these solvers is a base for projects that are actually going to be running this to adapt their own needs. It supports the OIF APIs, and it facilitates basically all of these management. It's very modular also in terms of which network and token it supports and which kind of actions are provided. So a key element in this is that a solver requires like context and estimation of gas on the intent that they are fulfilling to provide a good quote. So they need to have a clear trust assumption and a clear view of what's actually going to be executed so that they don't get drained or they don't get yeah, messed around. This REST API, I think I said too many times, like it's modular and extensible, but like it's really the foundation of this project. It's a very modular project, and this API is minimalistic at core, but extensible to the maximum. Basically, we provide classical metadata as like, what do you want for input? What do you want for output? Is there any trust assumption you want us to respect, like a specific oracle that you want to blacklist? Is there any like pair of tokens that you don't want to touch? Is there any time to execution that you require? And all of this gets formed into a quote, submits to the solver, and then the solver will give you all the data needed to sign to then propagate that intent. All of this is obviously a little bit complex to do when you are having to communicate with so many different solvers at the same time. So we built an aggregator. An aggregator, then again, is modular and extensible, and it also has a unique capacity that other than, or on top of being able to aggregate multiple OIF API solvers, we can transform the API to connect with other protocols that may not be fully OIF compatible right now. And we are able to transform their API calls to make it transparent to the end user. So OIF does not only support or does not only work for pure OIF protocols, it also works for other intent-based protocols. So now we are going to do a little bit more of a deep dive with Fran about an ERC that we've been working on together.
Okay, can everyone hear me? Well, yeah, awesome. So ERC 7683 is kind of its own thing, but we are working on it as a part of OIF. And in order to understand why it makes sense to have a standard, I want to take a step back and give an overview of the life cycle of an intent, which Pepe brushed on, but this is a bit of a more simplified view. So at the beginning, you're going to have a user. It's going to be interacting with an application, and they're going to express some intent, which is some outcome that they want to see affected. The app or the wallet are going to synthesize from that an order that implements that intent in some intent protocol. And that means that it's going to sort of verify that the intent is actually achieved. The user is going to get this order back, they're going to assign it, and then they're going to submit it to some order feed, which could be on-chain, could be off-chain, and from this order feed, it's going to go to a network of fillers, which are the ones that actually will kind of make sure that this intent executed on-chain. So that is the last arrow that we see right there, the fill, in which the filler will interact with the intent protocol or the settler contracts of the intent protocol to give the user their assets and then to verify that they did that and then get paid and so on. So the problem and the context in which the ERC comes in is that this last arrow that we see, the fill, is protocol specific. So it'll be each intent protocol will have a different interface, maybe even sort of a different structure of things that the filler has to do to get their payment or values that they have to provide. And so what this implies is that every filler will have to integrate with every intent protocol separately. So they will have to write up the solver that we're developing. They will have to make their own solver code for the intent protocol or use the one that's provided by the intent protocol. They will have to do separate audits. They will have to set up infrastructure that's specific for that maybe connect to some off-chain service. And so it'll all be very protocol specific, and that's a lot of work that needs to be done, right? It's development, it's reviews, it's audits, and so the consequence that this has for the intent ecosystem is that it raises the barrier for a filler to participate in an intent or for new intent protocols to come up, because it's very difficult to bootstrap this network of fillers because of all of that work that needs to be done. So the goal and the ideal that the ERC is going for, and that the authors originally sort of saw a problem and wanted to solve, is to say, well, can we have a standard whereby fillers just sort of are agnostic about the protocols that they are working with, and when someone comes in and they develop a new intent protocol, they can sort of get for free that filler network, and the filler can also get for free the order flow that goes to that intent protocol without doing so much development and specific integration that is currently required. So with this motivation, in April 24, Across and Uniswap got together and they built ERC 7683. It got a lot of interest from the industry, and we saw it a lot in like crypto Twitter and all of these logos, which really means that there really was something there. So they worked on it all throughout 2024 up until 2025. But as protocols started implementing it, they started to find that it wasn't really optimal. There were many things that weren't quite right with the ERC as it was originally spec'd. So we're going to go over going to go over some of these things that could be improved. So this is a part of the ERC. It defines some structs to encode orders. It defines functions to initiate intents on chain. And there's a few more things that are in the screen right now. And the problems that, these three main problems that the ERC had that implementers sort of discovered were, first, it sort of forces a lot of gas overhead in the intent flow. The two things that I highlighted here are that there are these really big structs that you have to submit to the open functions, and then this even bigger struct, the resolved one, that has to be emitted as an event. And this is a lot of gas overhead. And I think, we talk about gas a lot, but in this particular case, it's really interesting because, protocols often compete in having the best gas efficiency for their users. And if we have this standard that, it's very, very pretty and, standardized and whatever, but it has so much gas overhead, nobody's going to use it. So it's not really achieving the goals of standardization that we're after. So this was a really, really big problem that V0 has. The other problem is that the interface was designed in this escrow-centric framework, and I mean escrow here in the sense of Across, which is the first one sort of that Pepe mentioned, which is when you have to make a deposit on chain before you then go ahead and do the fill on the destination chain. And as also Pepe mentioned, there are some newer constructions such as resource logs that don't need that step, that provide potentially much better UX for users, and that we would also want to kind of fit in this standard. And so, in addition to this point about the lifecycle, there's also some parameters there in the order, such as the open deadline, that are included that, again, many protocols won't need. And like I said, it's adding gas overhead. So we've got this kind of thing where it's sort of pushing many protocols away from actually being compliant. And lastly, point 3 is that the ERC actually kind of realized that, well, there is this variety of protocols out there that is quite natural, right? Because if you're building a protocol, you want to do something innovative. You want to make something different with your protocol. Differentiate yourself from the rest of what's out there. So you're gonna have your own protocol-specific things that you want to build and to offer to the user. So they included this kind of very generic bytes order data thing inside that actually ends up doing a lot of the work of like protocols being compliant. You know, you just have whatever it is in standard, you just shove it in there, and it looks like it's good, but it's actually, you know, you end up with something that's sort of only semi-standardized because every protocol is going to end up defining their own kind of order data, and you're sort of back where we started, where every filler has to still integrate with each of these different things. So I'm just going to go over a few more issues that this standard has. This is sort of the other half of the interface that the standard defines. And I'm just going to, yeah, so you know, first problem listed here is that the proceeds and the costs of an order are only really approximated and in some cases like extremely coarsely. And this is the max spent and min received parameters there. And you should understand that it's very important, these things, right? Because when the filler, they're subscribed to this feed, they get orders, and they're going to sort of analyze each of these orders. They're going to assess whether the order is profitable. And if the order isn't profitable, they're going to drop it. And so representing the proceeds and the costs very accurately is really important because, you know, if you don't, the filler is going to most likely just drop it or be taking on more risk than they would be comfortable with. And again, this ends up with like a dysfunctional network of fillers, and that's not what we want. So the second point here is that, like I said, we've got some extra parameters like the open deadline that some protocols don't want, but we also have some missing parameters like the settlement deadline in this resolved order, which is very important because it implies like, well, if the intent hasn't been filled and settled at a certain point, the user wants their funds back, right? And I want to stop here and sort of point out why it's very important to give all of these parameters. Is because these orders, right, which the filler signs, which the user signs and the filler receives, are really the coordination mechanism where they are, you know, agreeing to very important parameters, and, you know, the funds of one will be locked in one place, and the other one will be sending funds to some other place and sort of hoping that everything resolves. But no, you don't want them to be hoping. You want them to have certainty that they're going to get their money back, right? And so parameters such as this settlement deadline that ensures that you know, users can get a refund if the intent is never filled are very important to include across the standard. And finally, 2 more points are this was built at a point where we didn't really have any good standards for chains and addresses. So in any multi-chain setting, you need to refer to the chain where you're sending funds or the chain where you're taking funds. And we have it here as the destination chain ID, for example, which would be using the EIP 155 chain IDs, but that's not really sufficient in, you know, when we want to have a wider reach. Like just as one example, StarkNet doesn't have a chain ID, you know, and they're a good friendly rollup that we want to be able to have intents to and from, and they wouldn't be supported here. And also addresses, here they're represented as a bytes 32, but that's not a standardized format in any way. Like, and in some cases, an address may not even fit in bytes 32, and you want to be able to support that. But again, you know, having this be standardized is super important for this coordination property that the standard requires. And so, you know, this was another problem that we had. And the final one here is that there were some parts of the interface that were under-specified, like this filler data over there. It's just like a bytes parameter, and then, you know, the filler has nowhere to see, okay, how do I even provide this value? It's the thing that's usually used to like put the address where the filler wants to receive funds, but you know, some protocol might want some other thing, and there nowhere in this interface says how to actually do that. So these were most of the problems that we saw. And that's what motivated us going towards a kind of an iteration of the ERC that we are calling V1. So to introduce the direction that we have taken with V1, I want to highlight first, the one thing that I think was a really good idea that V0 introduced is this resolve function and the resolved cross-chain order, whose role is, as you might see, it has no protocol-specific order data in it, and it attempts to be this comprehensive description of what the order is in an actually common standard language. And I think that was a really good idea that we took, and we even sort of furthered in the V1 that we are doing. So the way that resolution works is that the filler is now going to be receiving from the feed protocol-specific orders, but in some standardized sort of packet format that the ERC defines, and they, but they're going to be encoded in some opaque way that the filler won't really understand as is. But we introduced this role of the resolver. And the resolver provides a service of like taking these protocol-specific payloads and translating them to this common language that is standardized by the ERC that we're calling the resolved order. So when they receive it, before doing the fill, they go through this resolution process, and that can tell them exactly what the order entails and what steps to follow. So that is sort of the transition that we are making, and so the challenge then becomes, okay, how do we specify this resolver? It's got like a very difficult task of representing very wide, a wide variety of protocols and orders that they can implement. So the philosophy that we have taken with this redesign, which is essentially what it is, a redesign, almost from the ground up, except for this one bit of the resolver, is to try to use, as much as possible, these general purpose building blocks. So this is in contrast to what we saw before about this order data thing. That would be non-general purpose. And what we want here is to have like very general purpose things that can be used across protocols, so that the implementation of those things in the filler can be reused and doesn't have to be re-implemented. So what we have done is taken the notion of an order and try to pin down what exactly does an order consists of. And we have reduced it to these four things that you see here in the resolved order struct. An order in an intent protocol will imply that the filler has to take a certain series of steps, right? And the steps will be transactions. You can think of it in that way. And the transactions might be that I take a signature from the user and I submit it to a contract to pull the funds in. I then go to the destination chain and I send the fill transaction to provide the funds. Then I go back to the origin chain and send another transaction to claim my funds, right? So those would be like 3 steps that a protocol might require from a filler. And that would be modeled in the steps part. So let me take one small step back and explain like who writes this resolver, where is it, and yeah. So the resolver is, as I show here, is an interface for a contract. This would be a contract that lives in what is often called the periphery of a protocol. So say that Uniswap develops a new intent protocol, they would, along with it, develop a resolver, a compliant resolver, and deploy it on-chain, even though it only has a view function. And you will obtain then the address of the resolver. And they would implement it in a way that understands Uniswap's new intent protocol and is able to translate it into these generic representations, right? So this is a periphery contract again that would be used by the filler in this step that we showed before, right? So the resolver here is a contract on-chain. So it takes the protocol-specific order and it translates it into this format. Like I said, the first thing that's very important is, okay, what are the steps that the filler has to follow? The other important component of an order that we've identified is what we call here variables, and these are some choices that the filler has to make. Um, and that eventually would become like pieces of data that have to be injected in these transactions that have to be submitted on chain. And by choices, I mean things from very simple things like what is the address where I want to receive the funds, to potentially more complex things like, how do I participate in this auction? So to give an example of that, some intent protocols nowadays, including LeFi that we are collaborating with, are using Dutch auctions to do parts of the intent flow. And when a filler has to participate in a Dutch auction, they have to decide based on sort of the pricing function, at what point in time are they going to go ahead and fill the user's intent, and what price are they going to give to them. So it's kind of crazy, right? Because this is a very complex thing, but it's quite cool that I think we have actually achieved, to represent it in this generic way, which is the timestamp at which you send the transaction is a variable that the filler has to choose, and it's sort of injected in one of the steps as an attribute of the transaction that has to be sent, and that gives the filler all of the information that they need. So as I now move on to talk about assumptions, this last thing that I just said is very important. The goal here that we have is to take all of the information that is relevant about an order for a filler to know, and to put it in here in these general purpose building blocks that we're trying. So the next one is the assumptions, and this is kind of a trust assumptions kind of thing. The truth is that ideally, you would only sort of trust the intent protocol that you are interacting with. But sometimes there are pieces where there's, say, you call a contract that the user provides, right, to implement some sort of callback handler, and the protocol requires that that doesn't revert. And if the callback does revert, then you're sort of reverting the entire fill, and that may leave the filler at a loss. So there are these points, and it's not just something we've made up, it's actually something we observe in actually live protocols. You have to make sure that the callback that the user has provided will not revert. So we have to take this and represent it somehow, and we put it there in this assumptions field. And lastly, the payments field is the proceeds part of the order, so it's what the filler will receive. One note that's very important, as you will see here, there are a lot of bytes in this ERC, a lot of bytes types, but in contrast to V0, each of these bytes actually has a very specific format that has to be followed, and with a very specific semantics that the filler will assume. So one, let me think about what am I missing. Yeah, so we have solved here the problem about only approximating the cost and the proceeds. The way what we have defined here allows us to do that very accurately, and even to support these kinds of pricing functions, where it's not just a constant number of funds that you would receive, but that depends on the choice that you make. So we support auctions, like I said, and we also support resource locks, right? So not only escrow-centric like the version that we had before. Yes, so I am missing one thing that's very important to understand, which is, our goal here is to reduce the effort that is required from the filler to integrate with a new protocol, right? This was like our goal, the thing that we are after, but it's not really possible to completely eliminate that, because you at least have to know that the protocol isn't going to rug you, right? So the thing that we reduce this to is just a whitelist, right? And that is the goal. It is that the filler operator would be able to configure their filler software to say, yeah, I trust this protocol at this address, and I trust this resolver at this address to tell me what steps to follow, how to participate in the auction, and so on. And so that would be the only integration step required from the filler. And it's a little bit difficult because you do have to understand the protocol, but it's something that you can look into audits that professional companies have done. You can look at TVL and you can look at sort of ecosystem adoption. So filling a whitelist of protocols that you support is a lot easier and a lot lower barrier than writing up the whole filler software like we sort of had before. So this is just a little taste of what one of these resolvers looks like. Admittedly, it's not easy because it's doing a lot, but this is a part of the prototype that we built last week in this sort of build-a-thon that we ran with some community members. And so here what we see is one of these steps, right, is the step to call the fill function that we see at the very bottom, and we're saying what is the contract that we have to hit, what is the function that we have to call, all of the arguments that have to be provided, and these attributes that I mentioned before, right? Like, this is a call that you can only make before the fill deadline. And this is all of the information about this step that is relevant for the filler. So yeah, that was the overview that I wanted to give. This is really just kind of like an overview then of what this filler, what sort of the rightmost part of the life cycle would look like, or actually all of it, which is, you go from an intent to a protocol-specific order, you then encode this in this compliant packet, which consists of this payload and a resolver, right? And then you give that to a filler. And then going through the resolver, the filler can get a resolved order, which has all of the structural information needed to then go ahead and do the fill for the user.
Okay, thank you, Fran. So now that we know what OIF is, what's going to happen with OIF in the future? And it's something that we're still looking into how to solve, but there is a classical problem that we want to avoid, and is that this is a standard that is trying to substitute other standards. So there is a possibility of us running into like, okay, this is just another standard. The way we want to avoid this is by building along the people that actually use the applications, that actually build the protocols, that build the wallets, and that build everything around it, so that at least this is a recognized open source, fully modular standard. We understand businesses will try to come up with their particularities, and they will have their own nitpicks, and they may have their own APIs. But this is intended to be a fully open, available for everyone standard that everyone can use. And the way to get there is to expand and build together. We want to onboard new layer 2s. We want to make sure that the experience from getting to 0 to 1 is as good as possible. We want to make sure that the solver and the aggregator meet the demand from the protocol operators, the networks, and the community. We want to make sure, we want to facilitate existing protocols and existing wallets to be compatible with these APIs. And we are obviously open for all protocol operators and standards to come and build with us. And once we have these basic blocks with more oracles, with more wallets, with more things, then that vision that we talked about at the beginning of any new wallet being able to integrate this standard and connect to multiple solver networks, to multiple protocols at the same time, is going to become a reality. So now it's time for the demo. I actually had this fake quote prepared before, but it's now more true than ever, because as you've probably been suffering, the internet in the event has not been the best. So we're going to give it a try. We are going to take a look at a reference UI that we've built for demo purposes. So this is like testing UI that we've built inside the OpenZeppelin team. It was first intended to like test internally how, let me make it a bit bigger. It was intended to understand and facilitate testing of the APIs, testing of everything, but we've realized that it's also a very powerful tool to show to people the power of these things. So this UI basically allows you to swap between tokens on different networks. Right now it's connected to two different solvers. Each one of those solvers have, and now it's where the demo may fail because internet is working, awesome. So we have two different solvers. One is our mainnet and one is our testnet solver. The testnet solver, we can go here and see like the assets and networks that it supports, and same for the mainnet one. The idea, or the reason why we have a mainnet solver is not to test with real funds, because the tokens that we have in here and we have supported are fake USDC. It's more to ensure that people and protocols can build and test with real oracles, real RPCs, and the real building blocks that they will be actively using. So there is, like for me, there is a cool thing about the OIF and about the intent protocol that we've built, is that when you want to, for instance, pay for a coffee, the coffee will cost you $2, whatever amount of thousands of Argentinian dollars that is. But you will actually have to think, okay, $2 plus gas fees, plus the solver fees, plus other things, I have to send 2.35. And then the guy in the coffee shop will not receive $2, will receive 1.99999. So something that it was very important for this protocol is to be able to have an exact output number. So let's give it a try. Let's see if internet behaves. I'm going to do a transfer of 1 USDC from Optimus Sepolia to base Sepolia. Once I input my information, I can request for quotes. This is connecting to the aggregator that is deployed live. By the way, you can go to the URL above. I will show a QR in just a second. Bear in mind, this is testnet infrastructure. It's intended to be used, but you may encounter some hiccups. So the aggregator has now filtered, based on the tokens and networks that I have selected, which solver is able to give me a quote. In this case, it's just the testnet solver, because I selected testnet networks. Each solver will give you a quote with a deadline. A deadline because maybe, well, in this case, USDC is relatively stable, but maybe you are moving from Ethereum to Bitcoin, and the volatility in there may be higher, so the solver will give you just a quote for a minute, for instance, which is more than enough for normal use cases, but in this case, I've been speaking for more than a minute, so this quote is outdated, so I'm going to go ahead and refresh. The quote is the same because it's the same. Once I select this quote, it's going to give me a lot of information about what is going to happen. It's going to give me the solver that is going to be doing the fill, quote ID for reference, the information about the inputs and the outputs, and then I'm going to be able to, in here, sign the intent and propagate it and send it to the solver. When we think about how to integrate the OIF, all of these will be built into the app. So, for instance, in here, you can override the private key that is going to sign the intent for testing purposes, but in reality, it's going to be just built into the app. Just for preventing problems, I'm going to refresh quotes again and go ahead with it. So I'm going to sign. I'm going to sign the intent, and I'm going to submit it. Once I submit it through the aggregator, it's going to go through the full process. Hopefully internet stands and doesn't get stuck in the middle, but basically what this is doing is getting my funds transferred into the um, input settler via, in this case, it's a direct escrow. The solver is picking this up, and it's going to fill the intent. After the intent is filled, the oracle will pass along the message to the primary network, and the solver will be able to claim their tokens. So while, in this case, the oracle is doing things, we can go to, this was OP Sepolia Scan. And we can see this initial transaction that does not exist. Okay, maybe it's in base Sepolia. There we go. So we can see like this USDC was fully transferred. So the oracle, different oracles will take different times. The oracle will propagate the information, and the solver will be able to claim this back in the source chain. It's very important to choose the proper oracle, not only for the time that it takes the solver to get the money back, but also for the trust assumptions. And we have seen this will become one of the main areas where OIF will need to be modularized and executed. This may take a while, so let's go back to the presentation. This demo.
Pepe, I just want to make something clear, which is like, at that point, the user's funds were already delivered,
Yes.
right?
Yes. The user, the speed of the intent is super fast. So the user doesn't have to wait for an oracle. The user has the money. The actual intent takes whatever amount of time the solver thinks is safe for them to assume that the funds are properly escrowed. So if it is a higher volume, the solver may want to take proper finality time on Ethereum. If it is more day-to-day activities, it may be okay with a couple of blocks of confirmation. So you can all access this demo on oif.openzeppelin.com. Give it a try. You can freely mint all the tokens supported there. So, I mean, the solver doesn't have a lot of millions of liquidity, but feel free to mint, give it a try, and move funds around. Oops, sorry. We've also built this for the community. Like the open intent framework is supposed to be open. So there is a lot of documentation that we've put together at docs.openintents.xyz. And we also have everything in the OpenIntents org in GitHub. I encourage everyone to actually take a look, reach out to us if you are building things, get interested if you are integrating a wallet or you have a solver or you have a network. Reach out to us and we will be super happy to support on that. So thank you very much. We have 10 minutes. We've started a bit late, but we have a couple of minutes for questions. So if anyone does have any questions, I assume someone will be able to pass them a microphone.
Any questions?
Any questions? Yeah, can anyone pass a microphone to him?
As you said before, the first step is to commit to all solvers. Like, we might find to all solvers wherever is ready, wherever is
Hi. We've actually built a testnet app, which was a fork of privacy pools, and then open intents coming in and out. But one of the things we realized is we had to the create order interface of the open intent in order to provide that compliance layer of the associated set provider. We modified it to also prove that this address created the intent. So there's an extra dual oracle. And because we've modified it now, we can't just plug into the default solvers. They're gonna have to be aware of that extra step. Am I talking about this correct? Okay, so I guess yeah, we want a hackathon, but I'm wondering you're probably the right person to talk to in terms of how do we, because it's hard building on intents, right? It's not like before where you just build a contract, point it to an RPC, deploy it, and yay, it's a lot more complicated. So I guess I'm kind of here to find out what the next step is in terms of how do we connect to people running these solvers, how do we tell them about our modified order interface, and did we even do it in the right way, I guess. I'm really looking for feedback on that.
So I think there is two parts to it. The first one is how do you reach out to like existing solver networks, and the OIF at the end is a framework, and we run like a demo solver, but the reality is that the real solvers with real liquidity will be needed to like, okay, talk to me, modify this, and all of that. Right now, the biggest solvers networks that we are talking with are LeFi and Across. We can get you in touch, but like the reason why OIF exists is because very likely LeFi and Across will tell you like, come back to us when you have a couple of millions in liquidity. So the cool thing about OIF is that you can go, take a look at the solver code, ask someone with Rust experience to like take a look. It's very easy. We on the hackathon that Fran mentioned earlier, we got people running their own solvers, modifying their own solvers within a couple of days. So you will have to adapt to it. There is a second part to that is the 7683. So if you are able to like fully standardize and modularize the steps that your intent requires in a 7683 compatible system, the solvers following that will hopefully be easier to integrate. So I'm not sure, Fran, if you want to kind of expand
Yeah.
on that or like.
No, yeah. I mean, the first point is like, I'm not sure if I mentioned this, but this new version of the ERC that I described, I would say it's kind of like in final research stages, so not deployed yet. But if I understand correctly, you edited the contracts. The contracts, right? So that's like I think a perfect use case for, you want to tell fillers what they have to do to fill this. And in that case, once we have this, what you would do is you implement a resolver or you fork a resolver to properly work with this new field that you have and construct whatever data you need and so on. So I think it's a perfect use case. And yeah, I would love to know a little more and understand if it does work for it.
Perfect. Any more questions from anyone?
Hey, thanks for the presentation. I was curious, how's wallet adoption around this? Like from what I saw on the demo, and sorry, I'm a bit of a beginner around the intents. Like it's a standard like 712 signature. I'm curious if there is work on wallets to adopt the standard and make it more clear to the user what's the intent they're actually signing.
Yeah, there is. So there's two parts to that. First, there's wallets actively collaborating with us on like supporting OIF API, especially because LeFi being one of the biggest contributors to this, there is a lot of wallets connecting to them. The Wonderland team also are working on wallet integrations, and they are part of the OIF. There is also a standard that I don't remember the name about kind of facilitating clear signing of 712 data, and OIF relies a lot on that. So it's still going to be encoded. It's still going to be a layer of decoding that, based on current expectations, is likely going to live in an SDK, because when building the API, we had to decide, okay, do you trust the metadata that the solver is sending to you, and then you construct the encoded version and then set it on chain, or vice versa? So we went for the solver sending you the encoded with an extra metadata field that is, like, it must be used just as a helper, but if you want real trust assumptions, you need to decode it. So the first steps are being done to like facilitate this wallet integration. There is an ongoing work on SDK that will like actually be able to allow wallets to decode the data and fully like trust the data that they are showing. Okay, so unless there is any more questions, again, thank you very much for being here. Any questions? Happy to chat around. Thank you very much.
Thank you all.